Hello and welcome to the Weekly Iteration. Today we're going to be talking about a topic about which we are asked all the time. This is probably the most frequently asked question once you start talking about testing, which is when do I write an integration test and when do I write a unit test? The answer, of course, is, as always, it depends. But I think we're going to get started by asking a counter question.
So, why do you test at all?
So I don't get fired.
Yeah. But, why will I fire you?
Okay.
So we tell people all the time that tests will help you catch regressions, that if you want your code to continue working as you change it, if you want to be able to adjust directions rapidly, then you should be writing tests so you can catch bugs before they go to production. So that's a big one, and I do think that's real. That's something we care about. They can also provide direction to you while you're developing. So, writing a simple feature can touch many different pieces in a Rails application, and sometimes it's not really clear what to work on next. So a good test can provide you, the next missing piece in the link of things you need to write.
Which kind of keeps you in the zone, which I like.
We tell people that doing TDD helps improve the design of the code at a small level. And I think we actually have a whole episode on that where we talked about improving design using TDD. And sort of part of that is that you get rapid feedback. So not just like improving the design, but also as you're writing a class, like thinking about like, what do I want to name this method? Like, what should the arguments look like? It can be really hard to just start with that blank piece of paper. And so if you're just adding tests, it's much easier to figure out the code you want to write bit by bit. So those are the four things we're looking for is catching regressions, we're looking for feedback, we're looking for direction, and we're looking to improve the design. And so what I think would be helpful is to just jump into some tests somewhere on the integration to unit spectrum and talk about how they provide one of those four benefits and what some of the other sort of characteristics are of the test that we're looking at.
And then sort of the gist is that different granularities of tests will give you these benefits in different amounts.
Right. So, example number one. This one sort of gives itself away as an integration test for anybody who's familiar with the integration testing landscape in Rails because it's using the Capybara feature DSL. But let's just read through it quickly. We have a single feature, a single scenario. We're creating a user who is going to be looking at an exercise, and then we look for some things on the page. As an integration test, this is fairly high level. It operates mostly by going through the web UI. So it's not interacting directly with almost any classes. We do a little bit of direct database access just so we can skip the process of signing up and signing in every time. And that's purely an optimization. Like in an ideal world, we wouldn't have to do that. And so thinking back to those benefits, you can see how this would catch regressions, right? Because if we do a little refactoring and move things around and now suddenly, like, I don't know, the exercise title doesn't show up on the page, then we'll catch that, right? So this will catch regressions. It will provide direction because as you're implementing this test, it'll tell you what's missing next. So you'll see errors like, oh, I don't have this template. I don't have this controller. Versus if you're, say, writing a controller test, as soon as the controller is complete, it's like, oh, we're all green. Everything is good. You're done now. But if you don't actually have the view implemented, then it's not really going to work.
Or the route might be there, not be there, or there might not be a link to it.
Right, exactly. And this tests it more or less end to end. And then thinking of the other two benefits, improving class design. So it's actually hard to even see which classes are involved. As people who know Rails, we probably know there's a user model and an exercise model, but beyond that, there could be a number of classes. Since you can't see them, it's unlikely we've improved their design. And so this kind of test doesn't really provide feedback at that level of granularity. So it won't help you improve class design. It doesn't provide feedback as you're developing. So you'll probably want other tests to help you do that. Some other things that I think, beyond just those four benefits, some general characteristics of this test, you can see that it creates at least two entries in the database, right? So it creates a user and an exercise. It's also going to create any dependent data that you need for those to be valid. And so that's doing I/O. That takes some time. It also goes through the entire Rails stack through Capybara. So it boots up a fake browser. It goes through the routing stack, hits controllers, renders views, follows redirects, all of these things. And so this is not going to be the fastest test.
Right. So this kind of paints a picture for us of the strengths and weaknesses, I guess, of this level of testing.
Right. So we've seen some things. Like, it's good for catching regressions in particular. That's something that jumps out at you. But also, like, it's not good at the sort of code level of feedback, and it's also going to be slow.
Yep.
So let's take a look at another example. This one's pretty similar. It's another test using the same feature, DSL. This one creates even more data, so you can see it's going to be even slower. Again, it visits a particular page as a particular user and then looks for something on the page. So I think, honestly, this has pretty much all of the same characteristics of the previous test, right? I think this is something you'll see in general in capybara tests, is that they pretty much all have the same characteristics. They all have the same advantages and weaknesses. They're extremely powerful in a language like Ruby, where you want to make sure that everything's actually working together correctly, but they will also always have the same weaknesses.
Okay.
Think there's anything else worth?
The name of the trail is kind of awesome.
Baby exercises?
Yeah.
Well, you got to exercise your baby.
Absolutely. This is our stealth new product.
Yeah,
We'll be announcing this soon.
ish. All right, well, let's move on to another example.
Okay.
Not using the capybara feature, DSL. This is actually a pretty textbook model test, right? So we have a clone model. It's an active record model. Right away, we hit it up with some shoulda matchers there. It should belong to, should have many, have one. And so thinking back again on those benefits, number one, catching regressions. If you look at that first test, like, it should belong to an exercise. That's not very likely to catch a regression, right? Because if you like refactor and it's like, oh, well, I don't have that association anymore, I'll just delete that. Or, whatever, like, you're not actually using the association. This test is going to be like, great, it has, I see the foreign key, guys, it's good. The same goes for all the have many, have one. It's just nice to get that quick feedback, like, yes, I added an association, it is valid, all the necessary pieces for this particular thing, like a foreign key, are in place. And so I can move on without worrying about that particular error, but provides no value in terms of regression catching.
Yep.
Will it provide you with direction from a high level?
Yeah. If that test fails, it's pretty obvious where.
Well, it gives you feedback, but from a high level, like figuring out what you're supposed to do next.
Oh, not really.
Because, so if you're implementing, for example, viewing an exercise, once you finish testing your exercise model, it's not clear that next step is probably like a view or a controller action or something like that. And so it doesn't really provide that. It can potentially help you with class design. I don't really see any improvements there. Like, helps you figure out what the relationships are, so figure out what the collaborators are, but there's no great insight I would see coming from this test.
Right.
Feedback you'd be able to get very rapidly. And so, for example, we have this last thing here. It enforces the get SHA format. That would be very slow and annoying from a integration perspective. So you'd keep going through the UI and filling in different SHAs, I guess, and keep looking for the error on the page. It would take a long time to run. You'd have to add a lot of boilerplate to get to each next value. Whereas here we can just repeatedly say, like, this is a good value, this is a bad value, this is a bad value, this is also a bad value. And so I'd say it's really good for that feedback. And other just sort of random characteristics here, you can see that we never actually create any data. And so that will be pretty fast. It only touches one class. So that will also be pretty fast. It doesn't have to go through the UI, it doesn't have to go through the database, doesn't have to render templates, no routing, all of that. Looking at thinking about the previous tests, they were very high level, right? So it was stuff like, oh, this is on the page, but not very detailed, like what exactly should be on the page, what should the format be, those kind of things. Whereas this test, it's very easy and clear to test detailed things like, SHA and how many characters are allowed and things like that.
Yep. I like that before we had baby exercises and now we have parent SHAs.
Right, has a good symmetry.
We got a theme going on
there. So here's another example. This one is not an active record model, but again, it's a unit sort of test. And this one is sort of weird. We're actually iterating over a list of strings, which are debug levels. And then for each one, we generate an RSpec test. And we had said previously that the feature specs we had were like fairly slow, but the unit specs that didn't create any data were fairly fast. And so if you think about, like, you could still do this with capybara, right? Generate 5 tests, go through different scenarios, in generate permutations of them and run them all, and you'd get a lot of coverage, but it would be very, very slow.
Right.
Whereas it's safer to do something like this in a unit test, right? Like you know that each one of these runs in a few milliseconds. So if you add 5, it's like, I added 5 milliseconds to the test suite. I can probably spare 5 milliseconds.
Right.
So when testing all of those like random edge cases, like I want this to work for every debug level, things like that, unit tests can really be helpful.
This would also probably give us a decent amount of, well, some feedback on the class design.
Right, and actually the fact that you have to do this at all is feedback on the class design, because we're saying for each of these 5 methods, it behaves the same.
Right. That jumped out at me too.
Right.
It's like if our test is looking like that, what should our class look like? Like if we can use metaprogramming to just test all this at once, then can we just metaprogram it as well on the class side?
Right. Or could we narrow it down to like, should that actually be a parameter, for example? And in this case, we don't control the interface. Loggers are pretty standard in Ruby, so we have to write it this way. But if I got to the point where I was like, I either need to copy and paste this test or metaprogram it out, I would reconsider the class design. Because you do have a method which has a bunch of like iceberg functionality, right? It varies just a little bit for each method, but they're all really the same.
Yeah.
All right, so moving on. Here's another example of a pretty detailed one. And one thing that it's not totally easy to see here, but we're using more than one class in this test. We're using a shell and a fingerprinter, and the shell will actually execute shell commands. So a lot of people associate unit tests with isolation, which is valid, but it's good to think about what you're actually isolating it from. So in this case, I wanted to make sure that this class could validate a real SSH fingerprint and get the correct value back. And I could have stubbed it out to say like, oh, well, give it a fake shell and make sure it runs the command for generating fingerprints. But then it's pretty easy to, there's never any place in the test suite where you're checking that command is really valid.
That is an interesting distinction. That this is a unit test, but the unit is actually not a single class.
Right.
We often see units as meaning a single class, but this is actually multiple classes working in concert.
Right, and some people will call that like a component test or a service level test. But the idea is in a unit test, you want to test as few things as possible, but you need to test enough things together that you're actually testing something. And in this case, I did think it was important that you could get a valid fingerprint back. And so I wanted to make sure that it really ran that command that it's generating. And we do this in our model tests too. In the earlier model test, you didn't see us creating any data. But for example, if we have to test that SQL is running correctly, we will insert records into the database and run them for the model test.
Yep.
Here's another example of a similar approach. So it's not using Capybara, so it's not going through the interface. But I would call this an integration test.
Right, because there are a number of classes that are going to get hit along the way.
Right, and it's very high level. Reading the spec, you actually can't ever see which class is being used. There's this parse diff method out there somewhere, which is using the diff parser class, but it's using a bunch of other classes as well. And the idea is that we have this complex suite of classes working together to parse diffs and generate valid output that we can display in views and comment on and things like that. And each of those classes is also unit tested. But this full interaction is not very heavily tested through the UI. But it was useful to go through the different permutations of real diffs you can get. And so in the real file, this is just one it block. But there are maybe a dozen or so different diffs that we test, parsing all the way through. So not just testing like, oh, if I give you this diff, you should send this method to this object and maybe build an instance of this class. It actually checks to see like with all of the objects working together, if I run through the diff parser and then print out some strings back based on the objects I get, I should get this structure. And so it gives you a pretty high-level test. It's like this diff results in knowing that this file gets this content. And so I would call that an integration test. Even though it doesn't go through the UI, it's not exercising actually everything. But it is testing things working together to produce a business value sort of thing.
Yep, and so this is going to give us good regression feedback, good what to do next feedback.
Right.
Not so much on the class design feedback at all.
Right.
And a little bit slow maybe.
Right, and since it doesn't actually have to insert things into the database, it has that weird characteristics where you will get pretty rapid feedback. And so for example, like once you've gone through the first couple passes and parsed a few diffs, there are just a lot of edge cases to cover. And so what I did is I went through real commits that I had done in a repository and threw them through the diff parser to see if I would get errors. And once I got an error, I would make a new test based on that and go through. And you would very quickly get feedback that was like, I added this diff, I got an error. And then if you make the error go away, it's like, oh, I expected this file to be changed, but I didn't get any changed files. And so the feedback is pretty good, and they're pretty fast. But it also provides a decent amount of regression coverage and gives you the ability to figure out what you're going to do next. So this is kind of an interesting test because it almost provides, I guess, 3 of the 4 benefits. Just doesn't provide improvements to class design.
Sure.
I guess what's worth pointing out here is that it's not using Capybara, it's not a UI-based test, but it is an integration test, and it still provides a lot of value. It's just good to think about what type of test you're writing so you structure it the right way.
Right. Yeah, there's this tendency to view all testing through like the words that Rails uses to define them, and there's some more subtlety in there.
Right, you should actually think about what you want to get from it and not what the component is you're testing.
Right, and like integration test doesn't mean you're using Capybara.
Right.
That's they're not interchangeable.
Exactly.
Yeah.
Okay, so that's all I have for examples. But just to like recap quickly, based on what we saw in these examples, integration tests are good for catching regressions and providing direction. They're good for big picture things like a whole feature like viewing an exercise. There's this important gap in Ruby that they sort of close, which is you don't actually know if the method you're calling exists until you deploy to production. Right. But hopefully your integration tests do a decent job of catching that. Since the unit tests only ever, they test as few things as possible, they don't actually test many things calling methods on each other, but integration tests do. But unfortunately, integration tests are slow and hard to debug. The errors will usually just be something like, I thought there would be an exercise title on this page, but I'm on a different page, which is not usually.
Or just be like, there's not, and not even like, I'm on a different page.
Right. I thought I'd get this CSS selector. That didn't happen.
Right. Figure it out.
Discuss.
Yeah.
And they will also break when your UI changes because they tend to be UI based. Not all of them, as we saw with that diff parser example, but anything Capybara based, like if you are clicking on a link with a certain name, you'll be like renaming links and be like, oh, why did my test fail? Which is annoying.
One thing we didn't call out on that is when do you want to choose those benefits, or like sort of what the right ratio is, or something like that. Like I try to think of integration tests as mostly being like happy path, or like sort of a fairly minimal like make sure everything is plugged together correctly. So let's run through this, in one scenario where everything's going to work, and then maybe one particular scenario where I know things should not work, and then sort of drive out those little edge cases at lower levels. Like I like to see sort of a lot more unit tests than integration tests generally.
Yeah, we'll have to talk a little bit about like the ratio.
Yeah.
But yeah, I agree.
Okay.
So unit tests, on the other hand, as opposed to integration tests, are good for improving class design. Like they will help you figure out what your collaborators are, what your method should look like. You can actually use the code before you write it, which is nice. They're good providing feedback. They're rapid. They're good for testing low-level details, like making sure the fingerprint is correct or the validation messages are exactly what you think they should be. And they're fast and easy to debug. They will usually tell you exactly what's wrong. Like, I expected there to be 5 users. There are 4 users, and here are their names.
Right.
They don't catch regressions, though. Because they only test one thing working at once, they tend to miss real-world bugs. So things like, I'm not signed in, or I am signed in and I still can't access this page. You know what I mean? It's really easy to have that condition backwards in your unit test, but the integration test will catch it because it's actually signing in, going to the page, and trying to find some text. And unit tests, unfortunately, break when your implementation changes. So for example, if you have a unit test for a class and you want to split that class up, you're going to have to change your unit tests. Even though the behavior is the same from the user's perspective, that idea of like, oh, well, if you're refactoring, your tests just stay green is not actually realistic because you'll want new tests for the new class, and you'll probably want to simplify the test for the old class, and so on.
Well, I guess there's certain refactorings that wouldn't cause this to be true, right? Like you could refactor a given method as long as the behavior stayed the same.
Right.
But there are certain refactorings where you would, in fact, break the tests.
Right. So if you move around the internals of a method, the test should still pass. But simple things like renaming a method, for example, the test will definitely, they will hopefully fail.
Right.
Or moving a method to a different class. Those are textbook refactorings. They're from the textbook called refactoring, and performing those will break your tests if you have them. So you brought up the idea of like the ratio of tests, and Martin Fowler, who also wrote that textbook called Refactoring,
Yeah.
has this concept he espouses and that other people espouse called the testing pyramid, which is that you want to have most of your tests be unit tests and form sort of the large base of your testing infrastructure. And then in the middle, you'll have a select group of what he calls service tests,
Okay.
which I'd say are pretty similar to that test I had for the diff parsing.
Yeah.
They don't go all the way through the UI, but they do test something sort of end to end. And then at the very top, you have some very important but a small number of UI-based tests, which go through everything including the UI. And in Rails, that generally means using Capybara.
Yeah. One way I think about this is like what's worth UI testing is what's really important that it needs to keep working. Like if it's a SaaS app, like people have to be able to sign up and give us money, that kind of thing. Like we need coverage in the UI stuff for that. But if there are lots of like edge casey things, like what about when the card fails in this way, or what about if they get this kind of error from Stripe? Then those are sort of like unit level details,
Right.
or maybe service.
So I try to think of it like I want everything to be touched by the tests somewhere. Running all of the integration, service, and unit tests together should run all of my code. From the integration level, I tend to try and get all of my classes to run somewhere to make sure they all work together, but I don't necessarily test what they do. I just test that if I do something that does a lot of interaction with my classes, that I get some text in the page that shows that it worked at all. And then in the unit tests, I test all of the details to make sure that those classes are doing what I expect them to.
Yeah.
But I do think one great way to figure out how you want to structure your tests is to look at how somebody else did them and ask questions. And so some of our subscribers have access to the code that powers our application, Upcase, and the exercise system. And in particular, the exercise system, we've paid a lot of attention to this like sort of split of like UI, service, and unit test. We have a healthy smattering of all of them. And so I would definitely, if you want to see a good example of the testing pyramid, check out that application and see how we structured it, because I think it summarizes our opinions fairly well.
Yeah, I think people consistently report back that they learn a lot by looking through these repos, so it's worth your time to do so.
I definitely think after a run through this episode, a run through those repos is in order.
Yeah, cool. Is that the end of it?
Yeah, that's pretty much all I have to say about testing.
All right, awesome. As always, if you have questions, hit us up on the forum, and we'll see you next time. Whoa.
Cool.
I think that's not an error.
It's not. It's yellow. It means warning. Errors are red, Ben.
Okay, good to know. Like our logo. Do you want to take it from the top or from?
Yeah.
Okay. Now I know what your first slide is, though. I can set you up better.
All right. Maybe we should just do all these twice from now on.
Yeah, brilliant.
Or maybe I should show you my slides before we start.
Yeah, yeah.
So it won't really help you with that. Someday I'm gonna like live near bells, and I'll be in the middle of a conversation, and the bells will start, and I'll just be like,
And just hold.
yeah. You get, guys, bells. Hold for bells.
Guys, bells.
But yeah, I agree that you mostly want integration tests, and yeah, I agree.
Okay.
Great. Hold for planes. Helicopter.
What is with today?